Hey guys, welcome to tough and tricky question for JEE Advanced Work Power Energy. And trust me, this is a good question. So let's see, let's solve this. And this could be a potential JEE Advanced problem. So do not take this lightly and let's solve this. It's a good question. So okay, let's see. So the question states that a simple pendulum of length L having a bob of mass m is deflected from its rest position by an angle theta and released. The string hits a peg which is fixed at a distance x from the point of suspension, and the bob starts going in a circle centered at the peg. So the first part is assume that initially the bob has a height less than the peg. Show that the maximum height reached by the bob equals its initial height. Okay. So let's say this, let's draw the figure for this because this is a good question. You need to keep a track of what you're doing. So let's say this is length L. Let's say this is a peg right here at a distance x. So we can say that when this thing comes here, this thing right here is L minus x. Right? And this thing basically acts like a hinge. So as soon as this thing strikes this, some part of the string is stuck here. It's gonna come like this way. And so this is gonna come this way as well, and then it's gonna get deflected this way, like this, and then so on. Basically something like this. So let's see. Now it's saying show that the maximum height is equal to the initial height. Well, yeah, the maximum height is equal to the initial height because you see here it's all potential energy, and here no kinetic. And as soon as it hits this thing and then goes to some maximum height, let's say this point, here also there's full potential and no kinetic. Therefore, we can say the potential gets converted to potential and the mass remains constant. So we can say the height reached is same. So this was part A. Let's note down some important information, which is radius is L minus x. This could potentially come in use to us. Then this part here. Okay, so this is the part A. Now let's move on to part B, which states that so if the pendulum is released with theta equals 90 and x equals L by 2. So x was our height of the hinge or the bob, not the bob, the peg, yeah, the peg from the point of suspension. Find the maximum height reached by the bob above its lowest point before the string becomes slack. Okay. So let's say this is our thing. This right here is O. This is L, and this right here is L by 2. So this thing is, so the trajectory is going to look this way. It's going to come like this, like this, like this, and then it's going to go somewhere. And this thing's going to get stuck here, and then it follows the path. So let's use energy conservation to find the velocity right here. So you know it was left from here. This is 90 degrees. So you can use energy conservation to find the velocity here, which is taking this as a reference. So when this is taken as reference, I can say that uh, hmm, so this is L as well. This thing's L. So mgl plus 0 equals to ui plus ki equals uf plus kf. Uf is 0, kf is half mv square. So I can say v equals to root 2gl. And here you know that x is L by 2. So I can say that L equals 2 times x. X is the distance of the peg from the point of suspension. So I can say this is root 4gx. And here you guys know that x is also our radius of the circle which it goes after hitting the hinge, right? So after this thing touches the hinge or hits the hinge, then there's going to be a circular path which it's going to follow of radius x, which is the distance from the point of suspension. So root 4gx. Now here we need to start running our brain even harder, because when I say root 4gx, there's two things that comes to your mind. When it's root 2gx, it means there's an oscillation this way. Right? Remember, if you leave something from here, then it oscillates like this. If and here the velocity is root 2gx, but it's not in here in that case. The radius wherein being x, right? The radius being x. But now it's root 4gx. And remember root 5gx, wherein if you want to complete a full circular motion this way, then the minimum velocity at the bottom has to be root 5gx, where x is the radius. So here you can see it's root 4gx. When it's between root 2gx, if v is between root 5gx and root 2gx, which is v here is 4gx, then it's gonna slack. Then it's gonna somewhere, slack somewhere, right? This is the first important concept that we had to use in this thing. So just some important data which I want to note down is that the the radius is L minus x. The velocity is root 2gl or root 2g 4gx 4gx, wherein x equals L by 2. Okay, yeah. Now, so let me draw the trajectory of it so far, which we have figured out. So it's somewhat like this. This is L by 2. This one's going to be L. It's going to come this way. This the peg is here. Then it's going to slack, and then it's going to cross this part. It's going to cross this, and then somewhere here it's going to slack, because it's not going to complete a whole circle. Because if it crosses this one, then it's going to be a whole circle. Whereas in this case, it's not going to be a whole circle. So from here to here, now this, let's say is at angle theta with the vertical, and mg is this way. So you know this component is mg sine theta, but this is theta as well. So let me become more clear. So it's like this. Basically, this is the peg which is at L by 2, and this thing goes this way, like this. It's going to cross the peg which is right here, and it's going to slack somewhere here. Let's say this is the point of slacking, which is at angle theta with the vertical. Then this is where mg acts. So this is theta as well. I think we've done this a lot of times in our previous chapters as well. Now you can say that this right here is mg sine theta, which is tangential to this thing, and mg cos theta is what comes in. This is mg cos theta. Now I think some of you will think of it. First of all, it must be clear why are we saying that it's going to slack somewhere between the oscillation period and the full circle period, because the velocity is between root 5gx and root 2gx, obviously. Now, because mg cos theta is towards the center, which is my net force, which is also known as centripetal force. So I can say that mg cos theta is mass into v square by r, which is acceleration centripetal, which is mass into acceleration centripetal. Now the mass is gone. So I can say velocity equals r g cos theta and root of this thing. Now what is r? R was x here. X, which was L by 2. Right, so the velocity was root, so this is L by 2, which becomes 2v squared by L equals g cos theta. So v equals lg cos theta. So v equals lg cos theta divided by 2. So this right here is the velocity, the final velocity with which it's gonna basically go on a projectile. This is where it's going to slack, and then from here it's going to start off as a projectile like this, something like this, with the velocity v which we just found. So in case, I'm gonna just note this data down, which is v dash. I'm gonna put this as v dash. So v dash is the velocity with which it was gonna end the circular motion, which is root lg cos theta by 2. Root lg cos theta by 2. Now, one thing to worry about is, as you guys know, it's gonna slack here, right? And our goal is to find the wait. What was the question, bro? This question is so lengthy. Like honestly, find the maximum height reached by the bob. Find the maximum height reached by the bob before the string becomes slack. Okay, so one thing obvious is that right from here, right from here. Let me try it again. If this was our thing, if this was our thing, this is O. If this was upside X, this was string of length L. So this is gonna go. So it is gonna go here, this way, and then from here it's gonna go this way, this way, this one slack somewhere here. Now it's quite obvious that if this was L by 2, this also has to be L by 2, right? Because the string length is L. So this right here is L by 2. And you know this right here, this is how MG was acting. So this is theta. If this is theta, then I can say this was, so this is L, yeah, wait, 1 second. So this is L. This right here is L. So now this right here is L cos theta by 2. No, not L cos theta by 2, it's L cos theta. Okay. So this right here is L cos theta. This right here is L by 2. So the height from this thing as reference, this thing as reference is L cos theta plus L by 2, which is L into cos theta plus half, right? Oh yeah, my bad. This right here is L by 2. See, this question is very complex, I'm telling you. Like, it's for someone who has a lot of experience. But if you practice these questions, I can guarantee you your development of your brain, and it's going to help you a lot while solving, some new questions in your exam, because that's how advanced works. And this is only for advanced. If you guys are studying for main, just leave right now, because there's no point of, understanding all of this, right? Okay, so L by 2 cos theta. So this is L by 2 basically, and this is 1. Okay, so this is our height. Now here we can't, so theta was assumed by us, right? So we can't use any assumption to give our answer. That's why theta, cos theta has to be found. So let's use energy conservation for that, because we know the velocity and stuff. So let's do this, right? Energy conservation from point A, which is here, to point B, which is position of slack. Energy conservation from A to B, which is, so half. So down there, taking this as reference, I can say that the potential was 0, so kinetic is half into mass into. Now this is why I noted down the velocity here, which was root 2gl. Okay, half mv square, which is 2gl, plus ui was 0, and then uk for this. So for this it was m into g into l into 1 plus cos theta, plus the kinetic here is half into mass into velocity square, which in this case is this velocity, which is lg cos theta by 2. Right? Now let's use energy conservation. So mmm is gone, thank God. So this is gl equals to gl into 1 plus cos theta plus gl cos theta by 2. Now gl is also gone, which makes it much easier. Equals 1 plus cos theta plus cos theta by 2. Now I can say that 1 is gone. So 2 cos theta. So 3 cos theta by 2 equals 0. So cos theta equals 2 by 3 is what I'm getting. Now when I put cos theta equals 2 by 3, L by 2 into 2 by 3 plus 1, which is L by 2 into 5 by 3. So 5L by 6. So therefore we get our answer. Therefore 5L by 6 is the maximum height, or is the height above the ground from where the string has slacked, not from the ground, from the reference position. So let's say this is a reference position. So if this is the reference position, then from this point, the height is 5L by 6. So the answer to the part 2 is from 5L by 6 from the from 5L by 6 from the bottom point, from the bottom point of circular motion, basically this one. It is 5L by 6 from this point right here. This was reference, right? Remember, this was reference, so 5L by 6 is from this point. So now we have solved the second part, which was finding the height above the thing and the point where the string slacked. Now let's move on to the next part, which is the third one, which is find the minimum value of x by L for which the bob goes in a complete circle about the peg when the pendulum is released from theta equals 90. So we found out the velocity v here when the pendulum is released from velocity and at an angle of 90 degrees. The velocity was root 2gl, am I right? Now they're saying L by x ratio where x is something right here. Now the best thing for us would be if we lower the x, the more possibility it is for us to go in a circle. And one concept here is that for a circle, remember this, root 5gx, where x is the radius, is minimum required. So root 2gl, which was all the energy, all the velocity, the root 5gx was the velocity, right? It was the velocity which was required to complete a full circle, the minimum velocity. Now root 2gl is also the velocity which we got after energy conservation. So I can say when root 2gl is greater than or equal to root 5gx, then it is possible for us to complete the circle. Now because it's a minimum case, I can just say equals to. Now x, you remember, right? I told you this thing. X, which is the radius, is L by x, L minus x. So this right here becomes root 5g L minus x. So when I square, so I get 2gl equals 5g into L minus x. G is gone, so 2l equals 5l minus 5x. 5x equals 3l, x equals 3l by 5. So x by L equals 3 by 5. So let's write down the answers which we got. So answer to part 1 is, it was approved, so this was proved. Answer to part 2 was 5L by 6. Answer to part 3 was, um, it was, yeah, L by X ratio, sorry, X by L ratio was 3 by 5. Wait, it was 3 by 5 or 5X? Yeah, the X by L ratio was 3 by 5. Okay, I hope you guys understood this question. This was pretty tough, and I hope you guys tried it before me doing it because, see, the real benefit is when you guys try it before me. Otherwise, there's no point of solving such questions if you just want to look at the solution. I know this is a very, very complex solution. I don't know even if some of you even understood this thing because it requires a lot of understanding, conceptual, theoretical understanding to do this. But I hope you guys the best and just stay here. I'm gonna put many more tough and tricky questions for JEE Advanced. And by the way, this question is from verma. This is one of the best questions in work power energy. See you guys later. Bye. And keep learning, keep focusing on your studies.